EPITA 2018 fall semester mathematics. Okay, now exercise 6. So exercise 6 is like 5, exercise 5, but it's quite different. So it's almost the same thing. We have a sequence and then we need to show that it's convergent. Okay, so let me write un. So we have un is equal to this sigma k1 n 1 over n plus k. Okay, let me rewrite it again. I'm gonna write it here. Un is equal to 1 over n plus 1 plus 1 over n plus 2 plus etc. plus 1 over n plus n. It comes from here. And then again, I'm gonna write this like less than or equal to, more than or equal to. And my green pen, maximum fraction is this. This is the maximum one and this is the minimum one. And instead of how many fractions I have, the same question again, n fractions I have. So I'm gonna write the maximum one on the right, n plus 1 plus 1 over n plus 1 plus etc. plus 1 over n plus 1. Okay, you can see it. So how many times? N times, yes. And on the right side, I'm gonna write the minimum one. So here, okay, 1 over n plus 1 over plus n, etc. plus 1 over n plus n. And it's the same, n times. And you might ask why. The answer is in the previous video. Watch exercise 5, numerical sequence exercise 5. I explained there clearly. If you don't understand there, I tell you what to do. 5 push-ups and then watch the video again. Okay, let's continue. So how many fractions we have? N times 1 over n plus n, more than or equal to, we don't need to write this, we just write un less than or equal to n times, what's the fraction? 1 over n plus 1. And here this is 2n, so it's 1 over 2, then un less than n over n plus 1. Okay, now in here we can decide that un is bounded. No, I'm joking. Un is bounded. Okay, now the main idea is if we prove that un is monotonic. Monotonic means increasing or decreasing. Then we can decide that un is CV. CV means convergent. I just don't want to write it. So this is the main idea. So now, right now, I know that because of this inequality, I know that un is bounded. And then my goal is to prove that un is monotonic. So in order to prove that un is monotonic, we need to do what? This is the second step. We need to check un plus 1 minus un. If it's positive, it means it's increasing. If it's negative, it means it's decreasing. But like it's quite tricky here, so we need to find un plus 1 first. So I'm gonna write here un plus 1 is equal to, like, based on the given equation, we have k equals 1. You have to be very careful. Here it's n. It's n. All n changes to n plus 1. N plus 1. 1 over n plus 1 plus k. You get it? Yes. And if you expand this, 1 over n plus 1 plus 1, because k goes from 1 to n plus 1, plus 1 over n plus 1 plus 2 plus 1 over, okay, you don't need to write, plus etc. plus 1 over n plus 1 plus n. And how about the next one? 1 over plus the last one, 1 over n plus 1 2. K goes 1 to n plus 1. That's why k is here. Look, 1, 2, 3, 4, 5, n, and now k is n plus 1. So this is very important. I mean, if on the final test, if until here it's right and you got un plus 1 wrong, it means that you lose points. So this part is very important. So I'm gonna put exclamation mark. So you gotta be careful when you find un plus 1. So in here, this, and if you simplify this a bit, it's n plus 2 plus 1 over n plus 3 plus etc. plus 1 over 2n plus 1 plus 1 over 2n. Okay, and now un is easy. It's just k equals 1 over n plus k, which is 1 over n plus 1, 1 over n plus 2, plus 1 over n plus n. Okay, it's actually 1 over 2n. So, and now this equation, we're gonna continue here. So un plus 1 minus un is equal to, so un plus 1 is 1 over n plus 2 plus 1 over n plus 3 plus etc. plus 1 over 2n plus 1 plus 1 over 2n minus, what is un? 1 over n plus 1, 1 over n plus 2, etc. plus 1 over n plus n is 2n. So it's the easiest part. So like n plus 2 to 2n, n plus 2 to 2n will be cancelled. So we only have 1 over 2n plus 1, 1 over 2n minus 1 over n plus 1. If you just leave here, it's positive. You might lose points, so you want to show the professors that this is positive. So what we can do is, this is 2n plus 1. Why you didn't tell this? 2n plus 2 is 2n plus 2 because it's 2n plus 2 here. Because n plus 1 is equal to 2n plus 2. Okay. Now this one, we can write this as like this. 1 over 2 times n plus 1 minus 1 over n plus 1. First we try to calculate these two. Now we have 1 over 2n plus 1 minus 1 over 2 n plus 1. I don't want to explain how because it's very basic. If you don't understand, do 5 push-up again and then watch the video. And then here, the common denominator, 2n plus 1 times 2 times n plus 1 and 2n plus 2 minus 2n plus 1. And this is 1 over 2n plus 1 times 2 times n plus 1. And now we can easily say that this is positive. So okay, the conclusion part is very, very important. So for all n, un plus 1 minus un is positive. It means that un is increasing. This means increasing. And because we know that un is bounded, from this two, we can decide that un is CV. CV means convergent. Okay, that's it for this video. Cool. If you have any question, you can comment, but I'm not going to be answering this your questions because I'm not sure. So alright, see you.